Good morning students, class 9 general science chapter 1. This is the continued video. So we come to the topic what is called momentum. Do you know what is called momentum? Momentum is the combined force of mass and velocity. Mass and velocity both force if act together, this force is called momentum force. And this force was introduced by Newton. Who introduced this momentum force? This force was introduced by Newton. So this one is the momentum force. Here you are watching in images that one in football, the defensive player applies a force for a given amount of time to stop the momentum of the offensive player with the ball. So here this player increases its time to catch the other players. You are seeing here yellow color that player have, this one increasing its time to stop the momentum of the offensive player with the ball. So what we see that here with the player, both its mass and its velocity both are acting together. So this type of force is called momentum force. Now next we come to know, describe the first law of motion mathematically. So definitions, we know that when an object either moves in motion or in the state of rest, that object always remain in the same state, either in motion or at rest. So here how can we prove this one mathematically? Here see, the first law of motion can be mathematically stated from the mathematical expression for the second law of motion. We know that second law of motion, F equal ma. All you know, or F equal m because A equal V minus U by T. A equal V minus U by T. So in place of A, we have put up in the second line F equal m V minus U by T. Means V minus U by T equal A. Now cross multiplication, so Ft equal mv minus mu. Here we see when F equals 0 means if force is not applied. F means 0 means force is not applied. Force is a 0 application. That time V equal u means last velocity and initial velocity both becomes equal. This proves that when an object is moving in that motion, the last motion, final motion also remains the same if force is not applied on it. Now next, this means that the object will continue moving with uniform velocity u throughout the time t. If u is 0 means object is not moving, then v will also be 0. That is, the object will remain at rest. So in both cases, if f equals 0, so the object is in either rest positions or in motion positions or moving positions, they remains at the same state. So this way we can prove that the first law of motion. Now we know about some questions. This one, prove that F equal ma. What we can prove? prove that F equal ma. So now see, here I have taken pictures from book. Suppose an object of mass m is moving in a straight line with initial velocity is u, and it moves in uniform acceleration and gets a final velocity v and time is taken t. By the application of force, and force applied on it is F and the time taken is t, the initial and final momentum of the object will be p1. So initial momentum p1 will be mu. Momentum is indicated by p1, and the final momentum p2 equal mv, because final velocity v, so final momentum mv. This p2 is the symbol of final momentum. Now next, the change in momentum, last momentum minus initial momentum, so mv minus mu. Now m taken common and v minus u. Now the rate of change of momentum. By second law of motion, what second law of motion explain? The rate of change of momentum is directly proportional to the force applied on it and in the direction of force. So here force is m a and a is v minus u by t. So the rate of change of momentum is directly proportional to m v minus u by t. The applied force F is directly proportional to m into v minus u by t. Rate of change, to find the rate of change we divide by t. So F equal km v minus u by t. Here you are seeing that if variation here varies change, proportional change if we change in equal sign, then for that proportionality constant k is written and we remove this proportional sign. So F equal km v minus u by t, and now F equal km a, because a equal v minus u by t. Here what we see, that here a equal v minus u by t is the acceleration, which is the rate of change of velocity. The quantity k is a constant of proportionality. This one just I have told you. The SI unit of mass and acceleration are kilogram and meter per second square respectively. The unit of force is so chosen that the value of the constant k becomes 1. So for this 1 unit of force is, what is 1 unit of force? 1 unit, the force is equal to the force which produces an acceleration of 1 meter per second square in the object of 1 kg mass. So 1 unit force taken, then k into mass will be taken 1 kg and acceleration will be 1 meter per second square. And putting the value, we get here k equal 1. So now F equal kma 9.3 equation came. In that equations we put the value of k, then this becomes F equal ma. So this much today. Thank you for watching the video.